Industry 4.0. Hello, welcome. My name is Nico Schulze from the company 11 Dynamics. I am here today with Benjamin Ostrowski from the company Witte Barskamp.
Hello, Nico. Nice to have you with us today.
Thank you very, very much. And why we are both standing here today, you will see in this video.
Well, the automotive industry, currently big crisis, car suppliers are closing, no more cars are being produced because sales are declining. And in the automotive industry, the really big topic right now is virtual clamping. Benny, maybe you can briefly tell us why we are here today, what Witte has to do with virtual clamping.
We are out with our customers every day and have been for many years in the field of clampings. This is one of our core tasks here at Witte, and of course we notice what our customer wants. As you said, the customer is often in crisis, needs cost savings, needs higher efficiency, and that's how the whole topic of virtual clamping came up. We also want to contribute here and have developed a product together with our customers, which we believe is very close to market demand. We have named our product VIP Precision.
But as I understood it, with this VIP Precision device, which we also see in the background, you do not map the entire VC process. Maybe you can explain in a few words what your role in the area of virtual clamping is in the overall process.
We see our task, as with all our products, traditionally in component mounting. So far we know our traditional measuring fixtures in the area of RPS mounting. We also see ourselves in this area with virtual clamping. We want to hold the component. Together with you, 11 Dynamics, we have developed a product that holds the component. With your software, we have the ability to move our columns very precisely and approach the support surfaces, allowing us to continue placing a component very accurately.
I now see the fixtures with 3 pillars. As I understand it, this is intended for smaller components for a door or perhaps also a hood. What happens now if the customer wants to measure larger parts, for example, a side panel?
That poses no problem for us. It needs to be put into perspective. Yes, there are a few hurdles to overcome, but we are not limited to these 2 pillars. We can expand our product to a 4th, 5th, 6th pillar. With the product we see behind us, we have created a very large product because these specific needs were first brought to us. With this product, we can support over 50 kilograms per column at each column. So the load capacity is not the problem here either. However, we also have the same product for small, delicate components. I would say classic injection molded parts, interior parts. There we have a product that scales it down.
Okay, when you say you have such a large load capacity, I immediately think of electromobility. Does that mean you could also map entire battery trays with it?
That is not a problem at all, no.
Very good. Now the question arises for me, if I step into the role of an automotive person, I know the old approach, or when I was at VW or with the automotive companies, I have huge warehouses with lots of fixtures. What is your argument now? Why should I switch from this old world to the new world?
So here we have various arguments for our product. The first is, with our product, it is not necessary to buy a new Passivhagie. Often customers already have a grid plate, for example, in the measurement volume. We can build our product on that. Of course, if it's not available, we can supply it, but primarily it is already present with customers, we can build on that. That's one of the arguments. The next argument is that with just 3 columns, as we see behind us, I can cover a large number of components that I capture with it, and the classic measurement setup doesn't disappear. It just disappears in the sense that it stands on site. We relocated to a virtual measurement room.
When we are on the topic of conventional fixtures, I place the components there, they are fixed, and I am always 100% sure that they are in the right place. How have you solved it so that the user has assistance, let's say, for component positioning?
We have a camera system that we have integrated with a monitor. We can ensure that we can place components smaller than 3 millimeters with accuracy, and that is sufficient for the area to then measure and evaluate the measurement results in the virtual measurement room.
When I think about costs, as mentioned, virtual clamping is a hot topic. I've also seen other solutions on the market. What sets you apart from the competition? What do you do differently? Is the system faster? Is it more energy efficient? Is it cheaper? Maybe you can say a few words about that.
Of course, we are also aware of the competitive systems. Cheaper might be the wrong word here. We believe we have achieved the best price-performance ratio by saying we can use existing materials like a grid plate, for example. We don't need to create a robotic environment. We can use our columns in different measurement volumes. We are independent of manufacturers, and we can offer the whole package as an attractive overall package, and we believe we have a strength here.
What is your personal opinion? Will this device, because as I understand it, it can not only be used as a virtual clamping device, but also as a universal device?
This is also a possibility. The origin of this device was not virtual clamping. It is a byproduct that can fulfill that. However, we can also, for example, in a tactile world, attach stops to these heads and simulate a classic measurement setup. That means we can record with repeat accuracy. That was the first requirement that was brought to us. And with our in-house development, we have advanced it to the point where we can also cover the area of virtual clamping. Yes, and today we have made it an independent product. That's how we go to market. We have a classic universal fixture, I would call it, but with the addition that we can also use it in a virtual environment.
In your opinion, will this device eventually replace the conventional device?
That is a difficult topic. I don't think so at first. I do believe that traditional fixtures, especially when we talk about master jigs, will still be around for quite a while. I don't know what will happen in 5 years, in 10 years, with how fast-paced the world is today. However, I believe in the area of individual part measurements or maybe a roof, a sidewall. I do believe that over the years, this will be the path our customers will take, using this type of fixtures to capture their components.
Now I see, when I look at the system, you have used spheres as mounting points. Can you ensure that I can also position a component without stress?
Yes, here too we have developed a system, further developed it. We slightly lift our component, set the lower body into motion, and thus ensure that we, yes, get the tension on the component and can then specifically place it down again.
Can you briefly say something about the collaboration between Witte and 11 Dynamics? What role does 11 Dynamics play in this whole process?
That is a very good question, an interesting question. We see ourselves as specialists in recording. We see ourselves as specialists in automation. We see ourselves as specialists in how do I move such a column. We are not the specialists in how do I control the column. A jigsaw and what kind of software do I need for that? And here comes 11 Dynamics. I mean, your software is undoubtedly a very, very good software that complements our product optimally. And your software takes on the task. I load component data and move the columns towards the pickup points.
How I see the advantage of the system, because if I now have the task as a worker in the automobile plant, when I convert a system to a new component, that is time is difficult. This means the user can select the components in the software with a mouse click. The columns automatically move to the support points, and the worker really only has the task of placing the part, and then it is measured whether automatically or manually. That's another matter. But a lot is really taken off the worker's hands.
Exactly, that's correct. Yes, we can't completely take the responsibility away from the worker. It still needs to be checked. Yeah, where do I want to record? But that is taught once, also gladly in your software. And then I can transmit it to the system, and then I can imagine it like a button, like a normal up button that I have on my system. When I click it, the columns move into the correct position. They check if they are in the right position on the system, and I can pick up the component. So yes, I can proceed very quickly and proceed safely.
Very, very good. And now I see the system is also, let's say, fixed by the measurement volume. I would now have to take the columns and reposition them to adjust the system. What we saw earlier is very easy. Do you have any ideas to automate this process, to enlarge the system or the measurement volume?
We already have that possibility today. We can provide an accessory that allows the columns to move in X and Y on the plate. However, we believe that with the current state, as we measure in this area today, it is sufficient for now as we have introduced it to the market. But the addition is available, yes. If a customer already has the need to say, I want to switch from a small component to a large one, we can also provide a product here that makes this possible so that they don't have to move the column by hand with our mover.
We saw at the beginning that your AGV drove through the picture here. That means I could also put this device on one of your AGVs, and when I think about Industry 4.0, digitize the entire measuring room so that outside the components or the fixture are equipped and the AGVs then automatically drive into the automated measuring system?
Exactly, that is the big wishful thinking, that ultimately the finished pre-inspection is already aligned and goes into production, receiving the component. Here we are also open to which method we want to use. Do we want to have a robot that hands over, or similar possibilities that exist today, and the system can return to the measurement volume and measure the component? So yes, our fixed-based products are designed for that. And then again comes the strength of your software. This entire environment can also be represented in your software.
Now I'm wondering, a medium-sized company finished small sheet metal parts. Now a new order comes in and the component size, the component volume changes. What do I do with the system now? Normally I would need a completely new system. Can I somehow scale it, expand it, so that I can meet my customers' needs, so that I can handle larger components?
Of course, here at Witte, we will never betray our original company philosophy. This system is also modular. In other words, I can start with my classic 3 pillars, as we see the system here, but I can expand it at any time to a 4th or a 5th pillar. This is already provided for in your software, as you know. Here too, I don't need new software, I just need to expand the software. And of course, I can also move these columns to another plate, to another base plate. I am not trapped in one measuring volume. I can switch to another machine at any time. I can grow, I can add a column that is provided for here. Definitely, Witte will always support maintaining modularity in our system.
So the modular principle remains intact?
That remains intact, definitely. Perhaps also here to conclude this question, it is also expandable with other products. I have options, for example, when I use it with the classic, as we just mentioned, universal measuring setup. I can attach our blocks, I can attach our fix inspect products, I can also the mounting points on top themselves can be changed. So we have absolute modularity here. We are not trapped in this principle when I have the 2 columns standing.
Very, very good. I look forward to working together. Thank you. Thank you, Benny. Many thanks. Until next time. Bye.